Good evening, YouTubers. Welcome to episode 140 of Shrigleytube TV. Firstly, thanks for joining me tonight. If you're new, then welcome. If you're returning, then thanks for coming to watch. Please, Doug's just chill, mate. Anyway, it's been a great week. Got loads done, and we've had 28 messages, which is brilliant. Lots of messages to go through, so we'll go through all the messages at the very end of the video like normal. It's a bit of a short video week, so what I've done is I've stolen a video off the internet from the Roots archive and what I've done is I put it on at the end. It's great, it's really good. It's all about the Hillman being made. If you're thinking about buying a Hillman, when you see how they're constructed, you will be so impressed, you will want to buy one. So I'll let you get on with the video. Thanks again for all the messages and the kind comments. Yeah. I've got this here. We're going to start with this, which is Mr. Benoit's printout. We're going to clear up a few things and talk about that very first. Okay, thanks for watching. Right, okay, chaps, we're going to start with Mr. Benoit's printout. Now, obviously, this has been a topic of much discussion because I've had lots of messages and lots of phone calls, people saying, can we shift the torque curve further up the RPM range? Because obviously we can see it tails off here quite dramatically after 7,200. It's really on a decline. Now, the reason this engine behaves the way it does is purely the fact that we've put a 1200cc bottom end underneath it was basically an 875cc cylinder head with big valves and bigger ports. So the airspeed means that because it can't get the air, it just does more torque, whereas we'd probably see something a bit further on with like a 998 or a 1040. Not quite obviously as high as amount of torque, but the torque would be later on in the RPM range. So realistically, we've had a big chat with Mr. William Parry, and I talked to Bob about the cam. Bob said the cam's wild already. William says potentially a 4:1 will reduce this mid-range torque and hopefully put it back further up the RPM range. Lots of discussions going on. I think what we'll do is see how he gets on track and go from there. Now, one other thing I was going to say was this torque curve, I think that it fell off more than I've seen it fall off on a dyno. If I did a sweep from 5,000 over the 15 seconds it was running, then I think we would see it fall off similar because of the heat buildup in the engine. But if we'd have just put it on the rolling road and said to Pip, right Pip, load it up at 7.5, go to 8 and 8.5, I think we'd have seen more torque, and I don't think it fell off because I think this is heat. A lot of it is heat because it's been flat out from here. In the car, we have something called a climbing torque, so it doesn't work as hard as it does on the rolling road. It was really grafting there, and I mean, a lot of it is airspeed, but just getting too fast, but I do suspect we had a bit of heat build-up because you've got to remember we're not running with piston-cooled, oil-cooled pistons or anything, so the heat build-up in the pistons, they can't lose their heat, and obviously as the piston gets hotter, the first thing the cool air and the fuel sees when it comes in through the valve is the cylinder wall and the piston crown. So that's why F1 spend a lot of time trying to sort out the piston temperature, because they realise that if the piston gets too hot, as the gases come in, the first thing they see is the crown of the piston. Even though it's happening very, very quickly, you get a certain amount of expansion, which means you get less because the heat makes the gases expand. So you get less in the cylinder for the next bang. So yeah, I think if we'd have gone straight to 8,000, I think we'd have seen probably more like 90 foot-pound of torque rather than 82 or whatever. Well done, Dougie. Put them by the sink. So we move on to the horsepower, and Pip made a comment. He said basically, you know, if we change up and drop in at peak torque, which would be roughly 5,000 is where it's doing its good torque, and use this as our power range for changing gears, that would be the best way of getting around the track. And at the time I thought, I'm not quite in agreement, but I've had more of a think about it now. So what we're looking for is work done, and work done is the horsepower. So if we look at the horsepower here, we can see that the engine is producing, at 5,000 it's producing say 100 horsepower, but at 7,000 it's producing like 125 horsepower. So for me, in a minute mate, one minute, and for me, we want to be changing at 8.5 and or at 8.5 really, because we're still producing horsepower and dropping in. So these are our 2 points. Anywhere above 120 horsepower, from somewhere from, I'd say we're going to get dropped in at 7, because we've got 125, 126 horsepower available there. And remember, is horsepower is the work done, and that's why, if you want to understand it, just look at history. Lads, just give us a second please, can you go into the room? What happens is, if you look at like history with F1 teams and that, when they had the free reign, they didn't chase torque and do like big torque at low RPM. They went for 20,000 RPM engines. They weren't fussed about torque. They just wanted work done, bangs per minute. That is what is going to push you through the air and make the car fastest on track. So a rough understanding. I'm not saying Pip was wrong. I'm just saying that in Mr. Benoit's instance, where he's got good ratios, he's gonna be best off dropping in at 7 and finishing at 8.2 or 8.5, and just keep it in that area where we've got 125 horsepower available. That should push him through the air quite nicely. Good morning, YouTubers. It's Monday morning first thing. Just got into the chaos and I thought, oh my word, where are we gonna start? So I thought we'll start by saying hello on camera. I've had a nice relaxing weekend off with the Winklers and the wife, so we're going to get stuck into some production. I think I've got a bit of a plan, and yes, kit I didn't tidy up last week, so at some point today we will tidy up, but let's have a look around and see what we can get stuck into. Okay, so this was the small pinned offset board engine, blah de blah de blah. This has got loads of things that need to happen to it. I'm going to take the pistons off the rods and the rings, put them all in paper, or tape them up so I can reference them all back to the same piston, the same rod, the same bore, and we're going to clean the pistons up and get them welded. So that's one thing that's going to happen. The other thing that's going to happen is Gordon Bennett, what else is going to happen? We've got out here, maybe this will be the answer. Come out here and have a look. I'll put the lights on. Oh yes, I remember now. So I've got Simon Hull's coming today. He's going to sort out the dyno for me. So I need to, before he arrives, I'm going to try and turn these liners so that we can get building these blocks, or not building, gluing them together, because the borer is still set up for 74mm boring. So what I want to do is I want to do that, get these blocks bored, and then we can then deck them, and we can sort of put to bed doing the blocks, if that makes sense. So off all the blocks on the shelf, and we can just get on with cleaning, honing, production, etc. And we can clean all this lot up, and then the machines are free to be used for anything else that needs to happen, if that makes sense. So that's the plan. That's what we're going to do. I'll report back if anything exciting. Well, we've broken off from doing main work. Nigel hijacked me and took me for breakfast. How good was breakfast, mate?
It was superb.
I just had the pie. I had the race version. I had the pie and tomatoes. And Hulsey joined us as well. How you doing, Hulsey?
All right.
Mate, what do you think? This is a frame Hulsey's made, which is for this dyno. And we're just playing around with the frame now to decide where to put it. Now, what I thought was, Hulsey, I thought it might be more space efficient if we kicked it at an angle like that. What do you think? And then we could, well, we could put the door.
It makes your storage space.
Does it? Right. So you reckon over here, do you? Like that?
need to get down that side to the dyno, don't we?
Yeah, true. I don't know. Right, well, we'll have a think about it, but it's gonna take shape today. We've got the blocks. Where's the blocks? Where's the new blocks gone?
Someone's had them.
Someone's nicked them. They're behind the door here. We've invested in new blocks, so Simon's gonna get busy. That overhangs a fair bit at the back, doesn't it? I never saw that.
Do you need to get past that?
Yeah, ideally, yeah. Another 12 inches, that, isn't it?
Yeah. To get past it, you're going to a couple of 3 feet, isn't it?
3 feet. Chaps, it's end of play on Monday. Been lovely and dry here today, but I've got absolutely nothing exciting to report apart from the work that Simon's done in here. He's made the base. We decided to put it straight on so that it didn't play havoc with his OCD, not mine. And he's levelled it all up, done a lovely job. Obviously all that's got to go from there. But you can see we'll have plenty of space to get around it. It should be cool. And then we'll build the bulkhead along this line. And I was going to have a door that opened here, but Simon said, why didn't you make it a sliding door? And I thought, what a cracking idea. It'll take up less space as a slider. So that's all done. I've not done anything at the back here. Tomorrow we'll try and have a look at that. But for now, we'll just say good evening and I'll see you in the morning. Good morning. It's Tuesday morning. Now, yesterday we didn't have anything to record because we were sort of helping Simon with the base for the dyno. I did manage to turn a set of liners and put the flats on them, as you saw in the video just now. So I glued them in before I went home. I've got another one to do down there, and then that'll be the last 2 blocks. And we've got everyone covered on the list for an engine block, so we can move on to other jobs. But today I'm going to try and bore this and skim it, and I'll do a bit of videoing, but I'll try not to bore you too much. And then I really need to get the air out of the container, so we need to bolt the compressor down and run an airline from there into the main workshop. So that's the grand plan. Okay, chaps, it's Tuesday dinner. I've just been for the most amazing dinner with a couple that have come all the way from the New Forest with the most bravest Hillman Imp gearbox in the world. How you doing, Alex and Jenny?
Hello.
You right? How was your dinner? Was it all right?
Yeah, I was only lacking a pint.
Lacking a pint.
Can't-
Is yours
can't-
It was grand.
Oh,
Big
good.
pie and chips.
Pie and chips. Oh, I'm going to be massive one day, aren't I? You're going to come up here and be like Jabba the Hutt in the workshop. He's just been telling me some really scary stuff like this hasn't been apart for 10 years.
It was built in 2015
And
and it's been doing dozens of hill climbs
Right.
every year since. Well, obviously with COVID off, but you know, yeah, 2015.
2 years off, yeah. But,
2 years off, from 2015 to today, it's never been apart.
Wow. So what happened is, this is Alex and Jenny's engine here where we ran last week, and I said just bring your gearbox up and we'll have a quick peep at the crown wheel and pinion. There's a big inspection hole underneath. We'll put our thumb on it and we'll just see we can just feel what the clearance is like between that and the pinion and have an inspection of it. And then if it feels like we could make it better, we'll shift the diff across to close the clearance up. It'll just stop it from riding out a mesh when you launch it off the line, basically. But what we'll do is we'll inspect the crown wheel and pinion. If there's play to be had, what we'll do is we'll take the end off and we'll make sure the 2 big nuts are tight. There's one on the input shaft at the top and there's one on the pinion shaft. So it draws it back into its correct position against the bearing, and then we'll recheck the clearance and then we'll move the clearance across. But let's see what we see. Let's get the bottom of it apart. I'm really excited because this is a proper brave gearbox. It must have done 300 race starts or something.
Yeah, 30, 40 a year at times.
10 years, yeah.
2 of us doing it as well.
Yeah.
2 of you do it. Wow. And that is amazing.
And we drive it hard. We don't.
Oh, and I've watched the videos. I know you're trying to break it. yeah, brilliant. Right, let's get the bottom off and have a look at the crown. This is really hard for me because I'm a serial meddler. I'm struggling to leave it alone, but I took the inspection plate off and it just looks absolutely lovely. And it turns beautifully. It has got a little bit of play, maybe just a smidge more than tolerant, you know, the standard tolerance, but the crown wheel is, the pattern, everything's beautiful on it. So I'm just like, well, we're both in agreement, so all 3 of us in agreement. We're just gonna put the cover back on with a new O-ring and leave it be because there's just no problem with it at all. I normally when I take them apart, I go clunk, and it's like, oh wow, that was a good job we checked that, but this one just isn't saying that at all. It's It's really quite nice. So yeah, just keep doing exactly what you're doing with your racing starts.
Don't change.
Let the clutch get the grief and save the gearbox. Real, wow, I'll get a cover back on it. Morning, it's Wednesday morning. Bit of a different day today. Trying to work out the best way of getting through the week. We've got the skimmer going over there. We've got another block on the go. It's just about to start its pass over the final pass over the top. That'll be the second block. So both blocks will be bored and decked. And this is my Mark 1 imp. It's absolutely lovely Mark 1 imp this. It should have a curly edge block in it obviously, which I have got for it, and I will be putting it back in. At the moment it's got this engine in it which will be coming out, and I've got a customer who wants to buy a 1040 that I've got, and I thought, you know what, I haven't got a dyno, but what we can do is we can put the engine in this car, and he wants an across the back exhaust, so I thought we'll keep that manifold and all that, and then he can have the whole lot. What I'll do is rather than dynoing it, I'll put it in, invite him up, say there's the car, have a go of the engine, etc., and then he can have a go of it, see if he likes it. So I've got a 1040 with an R20 cam on the bench in the workshop, which I'm going to do a bit of fettling with, and then we'll bolt it in here and hopefully get it running before end of play today. First stage, just to take the bell housing bolts off, so got all those off all the way to the top. What I've done is I've hung the car over the back of the ramp. It's just amazing access. Really good car this, look at that. It's totally original. Absolutely split mint. Anyway, what I'm going to do next is I'm going to put the jack under the crossmember, the jacking beam, jack the back of the car up, put a battery between here and the gearbox, and then lower the car so the weight is taken by the gearbox. That will hold the gearbox still, it'll stop it from stressing the donuts, and then it gives you some, when you're putting a new engine in, it's always good as the gearbox isn't floating around everywhere. A quick update on the removal of the imp engine. What I've done is, that battery is completely dead, by the way, in case you're worrying it's going to earth out on the gearbox. That's underneath the gearbox, taking the weight, so the engine is completely suspended on the gearbox. The top bell housing bolt's got a couple of threads left on it, and it's ready to slide out. I've took the back panel off, obviously they're just dead easy, just a couple of little UNF 5/16 bolts from the side, and then there's one on the back of there, and the bumper bolt, and the whole lot just comes straight off in your hands. So what we're doing now is take the ramp up. This is where having adjustable height really helps. We'll take the ramp up, put the trolley underneath, and I'll just lower the engine onto the trolley till it takes its weight, undo the little bell housing bolt at the back, and the whole thing will slide out then. It's a absolute, got to be the easiest engine in the world to take out, to be honest, if you've got a ramp. It's not too bad on the floor, but honestly, it's absolutely bliss on this thing. I can't believe how easy it is. Okay, chaps, bit of an update on the 1040. We're going to call it the anonymous engine because I have got completely confused. I was convinced this 1040 had a R20 camshaft in it, but in actual fact, it's got a BJ65, which is our 400 thou lift cam. You can see the lift on it. It's a reprofiled R23. That's why it's on a small base circle. So it should go quite well, this. Big valve head, and not many heads I get that have this on it. It's an IS145, and IS of course stands for Ian Sykes. Is there anybody owning up to doing the block? I think, no, nothing on the block that I can see. No, so it's there's some markings there that I've written. What's that say there? About that, I was just trying to work out what I'd written on there, and what I've written is A38. So it's actually, that's Andy when I was 38 years old. Don't ask me about the coding for these things. So yeah, that was 10 years ago. Wow, no wonder I don't remember it. So it's a 1040 with an Ian Sykes head on it. So we'll get the cam cover on. I'm still desperate to get a tune out of this before I go home tonight because it's late night Wednesday. So we'll get the cam cover back on, get it back in the car, and let's see how it runs. She's in and running. This is one of the later engines that's got the rear oil seal conversion, so it'll stay nice and dry. Got the across link pipe on the back of it. I don't think we've got any coolant leaks either. So what we'll do is we'll go for a razz around it, see how it performs. Okay, YouTubers, it's Thursday morning. I've not been doing a great deal of YouTube at all, just been so busy. This is the airline that I've fed through the roof all the way out here. I've got my mate Lee helping me, bless him, he's come down. So the wire, the tube now comes out of there and goes into the building, into the container, because we've got the compressor in the back corner. What we're doing at the moment is just drilling the holes out for the engine mounts. You can see it's got one engine mount right there. Oops. We've got one engine mount on. They just arrived in the post, so I'm going to put some ramps on the container and then we're going to use the stacker truck to hopefully fit the dyno on top of the new brick bit that my mate's made for Mr. Hulse. So Lee's very kindly painted the top of that, just give it a bit of protection. We have run out of paint, haven't we, Lee?
Yeah.
We'll get some more to do the outside. But we've got a good bit of space this side. It's a good idea of Simon's to offset it, because we can have a little table here, you know, so if you've got to take something apart, you've got a little area to work. That'd be good, that. And then over here, obviously the compressor with the pipe. We've got to sort that pipe out yet. So that's all stuff I can do on my own. What I'm trying to do is as much of the big achievement stuff as I can do whilst Lee's here. That's rocking, that Lee. Next thing we're going to do is put the scaffolding tubes in. I've got a plan on how we're going to do it. And then we can put the overhead crane in on the runners, and we'll be cooking on gas then. But first of all, let's get this mounted on here and it's safe and dry and not outside. That's my main concern, because the weather, although it's very sunny in moments, it's very windy and it's very changeable. So yeah, I think that portally might go for a little walk if the wind gets any worse. Right, we were just about to put the dyno on top of the breeze block bit that Hulsey made, and Lee came up with a great idea, because it was just sat on it. He said it'll never bond to wood, so we'll take the frame off. We've laid it on underneath, haven't we?
Yeah.
And we've just drilled the holes. So now, when we go in, we'll go in, slide this under, boom, jiggle it around. Everything's going to go really easy. But we're not going to film it just in case it goes wrong. Right, I'm just giving myself a big pat on the back. I've got to say, I wouldn't have done it without my mate Lee. But it's dropped on absolutely perfect, hasn't it, Lee?
Yeah,
The brush marks don't quite line up with your paint, but it's there or thereabouts. So Lee was just making a comment. I think he's probably quite right in saying that the breeze blocks can't bond to the wooden floor, so it'd be wise to make some L-shaped brackets, and when it's all set hard, we'll put some bolts in that way and then bolt it to the floor so it can't shift.
Yeah, that's big base on that block as well.
Right, yeah. Just give it a bit of something. I know there's no torque transmitted through the bottom, but there will be a lot of vibration. That's why I've bought these Ford Cortina engine mounts, because I wanted it to insulate itself from the floor so it didn't shake all the cement out. Anyway, that's absolutely brilliant. Just in time before the weather turns on us, so the dyno is nice and dry. Another stage close. Okay, chaps, next part of getting the dyno sorted is an overhead crane. This is a piece of aluminium tube. It's quite thick wall, so it's got good shear strength. And I'm going to part this off into 6 pieces, and then we're going to slide this in the end of the scaffolding tube so we can create an overhead gantry for the big eye section. This is the eye section here from the old dyno. So it might be quite hard to understand, but I'll part these off. It'll just be quicker to part them off than grind them, being alley, and then we'll go from there. Okay chaps, it's Friday morning. Thought I'd start with a little video of the cold start of the 1040, which I potentially sold. Now, this engine is the one we took apart and discovered it had the full race cam in it. But unfortunately, obviously it's not been in my hands since before COVID. But anyway, that's another story. The problem is, it's got a rattle. On idle, it sounds like someone's inside trying to get out. Now, when they're on big clearance, they do clatter a bit. And then, you know, obviously the piston skirt clearance for race engines, we tend to keep it 4.5 thou. So I don't mind them being a bit clacky when they're cold, but this doesn't improve with temperature. So I think something's happened to it. Perhaps it may have got a little bit warm at some point and the piston skirt has picked up and yeah, just allowed it to obviously scuff the skirt, and then of course when it all contracts again you end up with a big clearance, so we just get a bit of tipping. As soon as it comes off idle it sweeps and up, but just on idle it's a bit clacky. So we're gonna have to pull that engine out again, and I thought to myself, it won't take long to sort it. I can't really sell it like that, so we'll get the head off it, get the sump off it, get the pistons out, give it all a good inspection, see if we can work out what's happening. Well, that's what happened today. Today we're going to talk about my progress from yesterday. So I did make a video last night, but the weather was absolutely atrocious. It was throwing buckets of rain at the windows, and the wind was really bad. So when I watched the video on this morning, all I could hear was the rain basically and the wind, so I thought that's no good. So there's the airline that I've fed through the roof down to the aqua blaster, so we can finally start cleaning stuff. And then obviously I was boring blocks over here and doing all sorts of other things, but the most progress you made was through here. There's the airline there coming into the container. So in here you can see the rain, it came in, it actually got to the wall there, it was chucking it down. So we started bringing the welding gear in here because we've got quite a lot of work to do. With Lee's help, we managed to land the dyno on top of the breeze block base that Hulsey very kindly made for us. Up here, those aluminium tubes that I was making on the lathe, we slid them inside the tube, and then I've used a pinch bolt to secure them. They fit inside some lifting hooks that were already inside the container. What I was keen not to do was to actually weld the container or drill the container. I wanted to leave it so that if it ever ends up a case where we need to sell the container on, I can just take it all down and I haven't got loads of welding everywhere and a mess. So these 3 bars, what I've not explained, sorry, is these are going to be for the overhead gantry. So we're going to have it's like a 2 U-sections channel bolted together, and then we have like a little 240 volt overhead crane that slides along here. So I can pick an engine up on the floor here, take it up, and I'll have it set diagonally so that it will basically cross the centres of this machine, this dyno, and then it'll finish above this one. So it just makes it so much easier when you fit an engine on a dyno if you can control the height of it on an electric switch, hover it where it needs to be, and you can make all your clamps to attach it. A luxury we didn't have when I worked at B&J. We used to lift them on, and it was always hard work. I'm not on for damaging my back and all that. I need to preserve the job as best I can. Anyway, the best bit as well was because I had Lee with me. He was just keen to get up the job. This bit of wood was just to protect the intercooler on the top of the compressor, because it's really delicate, and if it gets damaged, it'll leak its air and be no good. So this is the IVC that will have roughly about 600 litres of water in it, that feeds the head of water for the machines to work. It does 2 things. It acts as a brake inside the dyno, so the water wheel loads the engine up, but it also acts as a coolant for the machines, because obviously the heat, we've got all that energy, 100 horsepower of energy, it's got to go somewhere. So when the water breaks the power, it turns it into heat energy. So often with a Hillman we could run virtually for hours without it being an issue. But when you put a Rover V8 on or something with 200 plus horsepower, we've had the tank absolutely steaming with red hot water in it. But if it ever gets to that stage where we're running big stuff, all I'll do is I'll tee this off to an external radiator on the roof, and we'll put some fans on it. And when the water returns to the tank, because what happens is, sorry, I'm not being very clear here, the water comes out of this big container. We've even put it on stilts to give it a head of pressure. So with 600 ml of water in there, we'll roughly get about 3 psi of water pressure, just because the water is above where the dyno is, into the dyno. It cools the dyno and acts as a brake, and then the dyno sends it out the back, out that big pipe at the bottom there, and it just drains gravity into a catch tank. And then what we'll do then is we'll put an electric pump on the catch tank, and we send the water back into the top of the tank. So it just goes round in a circle all day long. But eventually, obviously, it absorbs heat. So we have to work out a way of keeping the water at a certain temperature, because the other thing I didn't mention was the water that goes through the dyno also goes through these heat exchange units, and we use that to keep the engine coolant temperature under control as well. So quite a lot to consider and think about, but this is the third dyno cell I built now, because obviously this is my third move. I try and move units every 5 years, so we're always trying to improve the job and move the job forward, because it's really easy to stagnate and just be happy with what you've got and get on with it, but never move forward that way. So this is my third dyno, and I know exactly how I want it to work, and I will make it work perfect first time with the air system. We're going to have 2 push air fans at that end, 1 scavenge air fan at this end, so we'll have a cross-flow air system. We'll insulate all the walls. It'll be quiet externally, because the one thing I learned off the last dyno I did, if you use fans to push the air in and a fan to suck the air out, the noise cannot get past the spinning blades. Much like a turbocharged car doesn't need as many silencers, because the turbo does a lot of the silencing. Just because the disruption, I imagine, of the sound waves by the turbo fins. Right, so this, I've really digressed, haven't I? This is the water tank, and all I've done, I found a cheap source for scaffolding parts, so we've bolted it onto the base, which I believe should be strong enough. And all I'm going to do is I'll put a couple of cross braces in this just to strengthen it up. We'll get the MIG welder in here, we'll just tack it. That's not going anywhere, and then what we'll do is we'll have to drill a couple of holes, unfortunately, and put some ties, and we'll hold that water back against the corners on each side. So you know, that's a lot of weight in there. So we don't want it to come away, because these poles, once they get anything from vertical, they'll have no strength and it'll just all come toppling over. So got to make sure that that's secure against the wall. Silencer, that's for the engines. Obviously I've got to drill another hole in there, and we're going to take the pipe outside, and then we'll take it right up into the sky, so the fumes go up that way and don't pollute anyone. Obviously we'll have to do a separate exhaust system for the this compressor, which I'm about to start work. Well, I was going to start work on it this morning. I'm going to bolt it down and do a few bits, but I've got a job that's a small job in the workshop that I want to get in the out tray, because this week has been really poor production wise. We have achieved, but it just doesn't feel like it, because there's nothing to go in the out tray. So I'll leave it at that. I'll stop waffling, and I'll say we've got a very special visitor coming today. His name is Vincenzo Frostini, a famous racing driver, famous Hillman racing driver. So hopefully when he gets here, we'll grab a chat with him. Okay, it's Friday afternoon. Dogs, what are you doing? And I've set about, we had a little bit of a window between swimming and finishing school, so I wanted to get this wheel off. This is the scooter engine for Dougie's little buggy. This is a plastic wheel with
I'll get it out, Dad.
all right, thanks Dougie. With a steel insert, so it's got a spline. So we'll take this to work, get on a lathe, get this steel hub out, because that's what we're going to mount the sprocket on. And also conveniently it's got the brakes inside, so this has got like a gearbox. We've got the engine, nice little reed valve block goes on there. All in perfect order. Carburetor flange was a bit knackered, we'll sort that out. Similar to the golf buggy. So it's actually quite a light, neat little unit. All this paraphernalia, all this stand's got to come off yet, so it will really be quite compact when we finish stripping it. I'll get the loom off it as well, find out where the plug is. And I think that'll mount on the go-kart, real neat. Dougie, rather than building waterfalls, can you take the wheels off the go-kart, please? No? Oh, no interest whatsoever. Good morning, it's Saturday morning club. Just in for the morning today. We've got an early finish, we've got some friends coming, so I've got to finish at 1, but yesterday we had Vincenzo. Unfortunately, he declined interview. I didn't want to push him, so I said, okay, fair enough. So we went for some breakfast, as you saw. Now, I've got a load of heads to skim. These are the 930 heads, and I want to do 5 of these skimmed, ready for blasting, so we can start the 930 job, because we've got quite a few customers waiting very patiently. This is a head for a guy called Mark. It's a 533, which is an L4 casting, and we've got a problem with the machine, and it's really interesting. Raymond Payne commented about my fly cutter being less than adequate, and he's quite right. Now, this fly cutter, we just always gone quite slow with it, but to improve the finish, I thought we'd go a bit faster, because we only ever used to have 1 spindle speed, but since Bernie fixed the machine, when he rewired it all, now we've got some more spindle speeds. I thought, oh, we'll go a bit faster and get a nice finish. So it did do a nice finish. You can't really see here, but what it did was it left a pattern in the face, because this was the first tool I ever made this, because I had no fly cutter, so I made it and I put different cutters in it, different angles to try it out, but it's not being balanced. So what happens is, when it gets to a decent RPM, it gets a shimmy on. You can feel it in the machine, and then it leaves a pattern. So we need to try and balance it somehow. I'm not sure how we're going to do it yet, but there's got to be a way. If we can balance that, then it should work fine. But yeah, I'm not quite sure. We need to get it between on centres or something and find its heaviest point. But anyway, we'll just slow it back down again for now and get the head skimmed. I'm also doing these starter motors, you know, doing the holes in them, elongating them, because these are Talbot Sunbeam starters, and we make them fit the imp, but the holes are slightly different. So they go in my jig here. I've got some steel inserts in here. Now, the thing that's annoyed me is this did work perfectly, but now I have to hand modify them afterwards with the hurdy-gurdy tool, because the jig has worn unbelievably. Anyway, that's life, that's what happens. Right, I'm going to crack on. If anything exciting happens, I will report back. Chaps, it's time for me to knock off. It's Saturday dinner time. Got this block clean now. This was the 930 that I'm doing as a kit of bits for the guy. So he's going to build it himself. His name's Mark. So I skimmed his head. I put guides in it. Just some new iron guides. I've turned his crank for 3 inch, so that'll go straight in there. So we'll get that ready for him on Monday. Out here, been a good achievement day. I've had no disturbances whatsoever. I've had to tidy up outside, put Bondi over to one side and stuff, so just so we've got a bit of room in here. Got race car on the ramp ready for the gearbox and the cross member to come off. My Hillman underneath, and the golf buggy, which is on eBay, which actually proved really good because I used it to push the imp up the ramp. It's got loads of torque. Anyway, I've skimmed 1, 2, 3, 4, 5, 6 930 heads, so they've all had the 80 thou off them. So that if you look at them, they're actually quite a low compression chamber. It's quite a good chamber for burn, but at 9 to 1 or whatever, they were useless. So we make them 10 and a bit to 1 as a 930cc lump. So they're all skimmed, because the idea is when I get one of the grade 1 930s to convert it for a customer, I'll have these heads blasted, skimmed, drilled and tapped, everything done on them. So we can just put all the new parts from the good head into these ones, which are a bit soiled, and they'll be blasted by that point, and then it just speeds the job up. So I'll have the crankshafts, which I've got on the shelf up there. All the cranks are ready to go. It just means that when it comes to doing them, we can turn them around quick, because I've got a few that need to be out imminently. Anyway, so we've done that. We've had loads of mess. Sorry about this kit from down under. I was going to hoover up, but I've run out of time. I've got some cast iron dust here for you from all liners that have been bored. I've done all my starter motors. They're all, I'll put them through in the back room now, so they've gone. So Monday morning, first thing, we'll come in. I've got one more head to skim, I think, and then when we've done that, we'll have a hoover up and we'll get the mop. I've got a mop and bucket now, so I'm going to get a mop out as well and mop the floor and clean the machines down. So I'll leave it at that for now. Thanks for watching. Have a great week.
Built on the Clyde, the magic phrase that has told the world of Scotland's mechanical genius since the Industrial Revolution. The world's first commercial steamship built the stuff of the Industrial Age, when the furnaces and mills, the forges and shipyards poured out their riches, and when generations of Scotsmen grew up with the 1,000 skills that were needed for the heavy industries. But the pattern of industry changes. The great heavy industries contract in a changing world. New industries must be born to carry Scotland into the new industrial age. Scotland turns to the exciting products of the second half of the 20th century, from plastics to hovercraft. And now, the newest of them all, the Roots Group prepares to launch a great industrial undertaking. At Linwood, Scotland's economy will leap into the high-speed age, the age of the automobile. In bygone days, famous cars were produced in Paisley. Now, near Paisley, a virgin site is cleared for the making of another famous car, a brand new car in the unbroken line of the great tradition of the Roots Group. In less than 2 years, Linwood is to become the home of the Hillman Inn. The fields are cleared, the pile drivers thunder, and one of the most modern car factories in Europe begins to grow. A bleak stretch of land has sprung into throbbing life. A desert has found a purpose. The planning of a completely new machine is a challenge to human ingenuity, inventiveness, and experience. Details of advanced design are worked out for management consideration. A car has to accommodate the human body. 4 human bodies, in fact. And of course the engine. And if the engine goes there, it leaves more room for people in a small car. Independent suspension, of course, and at both ends for a smooth, comfortable ride. Box-shaped for strength. Tilt the engine to save space. Wrap the whole thing in a tidy shape, and it begins to look like a real car. Every line, every plane of the bodywork is now modeled in 3 dimensions in small scale. A great many of these models are rejected before the designers are satisfied. The final concept is now submitted for approval. Lord Roots and Sir Reginald Roots bring a lifetime of experience to the project. Timothy, Geoffrey, Brian Roots, active members of a family team. And the time has come to try the body design in life size, on a full-scale model built in wood. Here the designers can adjust the final details of body shape. The car has been conceived. The first and crucial need of engineering is human intelligence, planned and coordinated. Every single mechanical piece has to be designed to fit precisely. There are thousands of these, and no matter how small the piece, it has to be machined and finished to the closest tolerances, from material chosen to stand up to the extreme demands of motoring anywhere in the world. For the engine block, aluminium. It saves enormously in weight. suspension wishbones in robust steel. Mechanical parts of the imp now spend months of agony on the rig tests, which compress a lifetime of torture into a few weeks. The rubber universal joints are made to last. And on this rig, the wheels, the tires and the suspension go through a worse time than they'll ever get anywhere on any road. And now for even more punishment. At the proving grounds of the Motor Industry Research Association, a car can be thrown round the banked circuit at top speed for hour after hour. There are places for going up and for coming down. Belgian pavé is renowned for its brutality to cars. And round on the skid patch to test stability. On the chicane, the car is made to corner at high speed. Steering and stability are under heavy pressure, but the new imp has to be fit for tougher handling than its owner will ever give it. It has an enormous safety margin. And now for the long distance work on every kind of road. Through France. France has its killer roads, old military tracks through mountainous country. And on these roads, one slip could be the last slip. On to Italy. On an autostrada, a car can be driven fast and hard for long periods. Constant checks are kept on fuel and oil consumption and on engine performance. It's easy to find sub-zero conditions in the Dolomites, but through mile after mile of soft snow and hard snow, the imp skims along without faltering. And on through Austria to Belgium, top speeds and top reliability for touring. And over to Africa, where the test drivers choose conditions that a city motorist would find a shade disconcerting. And the imp has emerged as a car equally suitable for jaunts or jungles. All the components are checked in tests from America to Africa, from Canada to Kenya. This car must keep going in every kind of climate and terrain, through the heat of the tropics, or into the everlasting cold in the Arctic, where 40 degrees below is normal and accepted. The car of today roars into a land of legend, towards the latitude of endless night. For some motorists, this is the only kind of world their cars will ever know. In the far north of Sweden, under conditions like these, a car must have reliability. It takes everything a great car can give to move fast and move safely and keep on moving in the land of the midnight sun. And now the production team is ready to roll to full-scale manufacture. At the pressed steel plant at Linwood, strip metal arrives in vast rolls to be uncoiled. It's cut to size. And it's stamped into shape. The great press line is a masterly blend of mechanical power and human skills. Raw sheets are swept into the presses, which force them into curves and curves upon curves. One flat sheet and, hey presto. The Hillman imp is of unitary construction. The individual pressings are now on their way through the vast and complex multi-welder, a robot of a machine that will fuse a dozen sections into one to form the basic structure of the car. From the welding jig, it comes as one piece of steel, light yet immensely strong. The completed body shell leaves the assembly shop and enters the paint shop. First, the priming coat is applied. Paint is important, but it must give lifelong protection as well as pride to its owner. The color range for the imp offers a choice to all. In the huge trim shop, the painted shells receive detail attention. But the imp still needs the most important thing of all, the power to move. Aluminium, amongst the most exciting metals of our day, is one of the secrets of the imp's reliability and vivid performance. Aluminium engine parts are made by Roots at Linwood by high-pressure die casting. Die casting means faster production and bypasses the need for lengthy machining, and every single piece is rigorously examined for perfection before passing to the next stage. In the unit machine shop, other components are finished to the finest limits on automatic machines. Gear cutting machines operate with a brain of their own on the link line to produce pinions to stand the stresses of the motorway era. Gear cutting is the high precision work of engineering. And this precision is minutely checked. Modern machines that make modern machines are synchronized like a ballet or like a mechanical symphony. And their effortless timing is controlled by an electronic conductor, a complete suspension unit of brilliant design. In transmission assembly, the tracery of overhead conveyors brings to the line the components to be assembled by human skill. And now it becomes possible to see the meaning in the smooth flow of a modern assembly line. Gearboxes for the Hillman imp. Are moving to meet the suspension units they are destined to marry. In this most advanced assembly shop, there are no haphazard meetings. Every unit has an individual identity, and it will be joined by its own mate and no other. Each car is a combination of units meeting in precisely the right place at the right time. Every car has its own identity, its own birth certificate, individually planned before it was born. Every item of the finished machines is inscribed on a punch card, and every point can be checked continuously by the electronic control system at Linwood. Every car is a combination of varying requirements, in colour and trim and detail, all made to meet the needs of different world territories. And now the parts approach the time of their total assembly, united with the power to move, and the wheels which give mobility. At last, the car moves off. A list of components has become the Hillman Imp with a life of its own. And the final checks are made before the brand new Imp is released into home and export markets. To all things, there is a season, and man's labour has its season of pride when the long time of planning is over and his work is ready for the world to see. The great Root's development is celebrated with pride on its appointed day when His Royal Highness the Duke of Edinburgh formally opens the Linwood factory. The Hillman Imp offers the pleasure of modern motoring to ordinary people all over the world. But to succeed, it must satisfy the exacting demands of all motorists. The Duke brings the experience and skill of an enthusiast to his interest in the new car. And for the true enthusiast, it isn't enough merely to look. Now they come, first in hundreds and then in thousands. The world is waiting for today's most advanced light car, and the Hillman Imp goes out to meet the world and win it.
Congratulations, you've made it to the end of episode 140. How good was that video from Roots Archive? Absolutely brilliant. Young Dom Smith, the keen young imp, put that on Facebook midweek and I copied the link, so hope I've not broken any rules there, but don't not now, mate, please. But so yeah, what an absolutely cracking video that was. And you see the way the pressed steel works was and just how much effort went into making them cars and in Scotland, and the logistics of it were just crazy. But they still made them from 1963 to 1977, so a lot of time and a lot of cars. I think that's why so many of them have survived, you know. Anyway, I really enjoyed watching it. I've watched it about 3 or 4 times. I was thinking of doing a voiceover and putting my own 2 penny with him, but let me know your thoughts in the comments and maybe we'll do that for next week. Okay, thanks for watching. Have a great week and I'll see you next Sunday at 7. Bye for now. Okay, chaps, we've got the piggles on. Excuse the visual on my head. Right, we'll get stuck into these video comments. We've got quite a few to get through. I'll start with Chris B8075. Firstly, thank you as well for all the comments. Do appreciate everyone making an effort to message me. I noticed that your rally customers use comprehensive air filters, yeah, when the dust they need it. Road cars use a combination of coarse or fine mesh trumpet filters. Never use fine mesh. Track cars often run with open trumpets, as I do on my sprint and hill climb K series. Have you ever done back to back on socks, panel filters, mesh filters to see how they affect power? Yes, not recently, but in the old place I did a lot of, not perhaps on YouTube, but we tried the K&Ns, we tried the mesh, all different types of filters. The airbox works best if you can get cold air to it. The K&Ns make them go rich, but then if you lead them off, they will do the same horsepower. The fine mesh absolutely crucifies the job, especially the faster it goes. And the coarse mesh, although it doesn't offer very good protection for the engine, is the best compromise for stopping stones getting in, but not touching the horsepower. Now, I've had a few comments on this about the mesh, but that coarse mesh, I have used it back to back, I've checked it, and I think it may, if you put it on a 2 litre Pinto or something like that, it may be different, but on a 1000cc imp with 250cc a pot, on a 40mm trumpet like that, with that coarse mesh, it is not enough air resistance. What you've got to think is, don't think of it as the engine sucking the air. It isn't sucking the air. The piston merely creates a vacuum for the air that is waiting to go in from that atmospheric pressure to go in through the carburetor. So the best way of describing it, if you've got a compressor and filled it full of a big vessel and filled it full of air at 14.5 psi, well, our atmospheric pressure, yeah, and then opened a hole in the side of the compressor that big, same size as your trumpet, just think about the amount of air that would want to go through that. It'd be massive. No, that coarse gauze is not going to bother it. Thank you for your comment. Right, better hurry up because we've got like 28 of these. Ashley Reed 3141. Brilliant. Trade plates in the racing brought back a flood of memories from when I was trading rally cars and trade plates in a 6R4 Escort Cosworth Mitsubishi or whatever was commonplace for a quick road test. No pics or videos as it was just daily occurrence. Great that you're showing what's involved on Shrigleytube. Thanks for the videos and keep up the great work. Right, well that's great, mate. I'm glad it brought you some flashbacks there. Yeah, you can't beat a bit of a road test on the road on trade plates. Bit of danger to your life, it's good, isn't it? Well, thanks for your comment. Ted Cowboy. Why are you using trade plates in the imp? Surely it's tax and MOT exempt. Yeah, it is, you're absolutely right. It's just, I thought it was actually on the database and tax and all the rest of it. When I checked, it wasn't. So I thought, just to be on the safe side, I'll throw trade plates in it. But I must dig the V5 out and do it because, like you say, it's MOT exempt. Raymond Payne, you need a multi-tooth milling cutter. Would cut the time, not that old fly cutter. Yes, you're absolutely right, Raymond. It's just that when I've got something that works, I'm sort of loath to change it. I know it's slow, but I leave it clunking away while I go and get on other things. So it's not like it holds me up massively. And I'm dead keen for the cutter to cut and not rub. So when it starts to rub, I just change one tip because I've only got one to change, not 20 tips. So yeah, if I was into like mass production and doing hundreds of blocks, fully agree. But for what I'm doing, I'm more than happy. And I gave you a mention because we speeded the machine up, as you saw in the video, and yeah, we had a vibration issue, an out of sync issue, which we sorted by slowing it down. Anyway, thank you for your comment, Raymond. NO13B, cracking video, Andy. Always appreciate the detail you go into. Thank you. We do try and talk about what's going on because that's what's important. We all want to learn something, don't we? Especially me, I want to learn. Got lots to learn. I do reckon that you could rotate the torque curve and move it up a bit with a shorter exhaust primary length. Obviously, you lose low down power. Think these imp engines always exceed all expectations. Yes, they do always punch above their weight, don't they? And funny you should say that because William has exactly the same theory. And what we're going to do when we get sorted with the new dyno, that'll hopefully have like a printout available, we're going to get William down with a dyno setup on the exhaust pipes. We're going to get our standard 1040 race engine and we're going to spend however long it takes, 1-2 days, get through loads of fuel, and we're going to carry on doing back-to-backs and learn exactly about step primaries, what length primary, what length secondary, what works best to put the power where we want it, like we discussed in the video, so we keep it on the boil between them two ratios. So that is something that I'm really keen to do in the future, because we have done a little bit in the past, but nowhere near like us. There's still loads of gains to be had, I'm convinced of it. Right, thanks for your comment. Right, 69 Wavy Davy. I recognise that stretch of road. You drove right past where I go camping a couple of times a year. I have noticed a few unused garages along there in the past. Is yours close by? Yes, I'm on that road, and there is a few garages on that road, yeah. And they're not just used, they're all got people in them. But there's all sorts. There's loads of motorsport where we are. Can't believe it. It's like 3 people on site that do motorsport. And then there's places down the road, and it's crazy. Anyway, thanks for your comment. Stephen Goldsmith, F6H. Andy, are there any drag coefficient figures you are aware of between the saloon and the coupe, as it would seem the special saloon boys tended to run stiletto silhouettes, whereas CSCC boys all seem to be running saloon shells? Yeah, they run saloon shells because they've got to, because the cut-off date is 66, and the coupe didn't come out till 68, so that's where that came from. But I am sure someone may be able to pop up the figures. No, don't touch that.
Does it work?
That's a lighter. You're not playing with that, mate. No, I'll look after that.
I don't want to play with. I want to not my screen. And then I want to melt it.
Okay, mate. Just not now, yeah? We'll make it later.
And I need fire now.
Sorry. Yeah, so if anyone's got any coefficient figures, I'd be really interested to see them, but I'm sure that the Imp Saloon is absolutely terrible compared to a stiletto, hence why back in the day all the special saloons were stilettos. Thanks for your comment. Haven View, this is my mate Stephen. I seem to recall last time you did a hill climb, you were fantastic going around the bends. Very kind, Stephen. I'm not so sure. So I'm sure you didn't manage the plastic freewheeler, no trouble. Perhaps we can all chip in for a set of front stabilizer wheels for you. You won't need stabilizers. Like I've said a million times, the Bond, because he's got his engine over the back wheels, it is very, very stable, incredibly stable. It's like a trike. It's absolutely ace. I'll get it on the road and show you one day. I was involved in the 90s. Sorry, and thanks for your comment, Stephen. Factory Fettler. I was involved in the 90s with successful BSB racing team engine tuners. We were desperate to get more compression, and a lack of race pistons available forced our tuner to try welding the crown of the pistons around the squish area and remachining the tops of the piston. After much concern about reliability of those welded up pistons, they were used in a couple of superbike engines revving to 14,500 RPM and producing good power with otherwise unattainable high compression, around 14.5 to 1. Wow, you must be on good fuel. Sure enough, they work perfectly and are still being used in a plastic parade race bike to this day. In a classic parade, sorry. Suffice to say, I wouldn't do this for a customer race bike engine, but on the imp piston that you are prototyping, give it a go. By the way, your pistons are 98 to 2000 Yamaha R1 4XV. Regards. Yes, I forgot the original ones were Honda, and then we found them 5-valve ones which were also 74mm on the same size pin that had the 3 cutouts, but there was more meat underneath them, so we could machine our valve cutouts deeper for the imp. That's why we went to them. So thanks for your comment. I'm going to weld them pistons up when I get my welder set up, and we'll give it a go, because the guy who was going to promise to do the laser welding hasn't shaped us yet. Ross.
Hello.
Just give me a minute, mate. It won't be long.
All right.
Right.
Can I get something to eat?
Whatever, yeah. Graham Crompton, 1798. Thanks, Andy. I've missed seeing imp engines running and getting tested. Yeah, I have too, mate. No dyno time. Isn't it good that the offset bore engine didn't hurt its bearings with the heat and thin oil and high RPM? It was remarkably good, wasn't it? I did see the pressure dropping and pull in as the oil got to close to 100 degrees. So, yeah. But we'll go again with that once with thicker oil, I think. And then when we get the oil temperature completely under control, we will go back to the fin oil.
Subscribe.
Sidecar bod 1441. I think that some of the ignition issues on that 1200cc engine are down to what the customer and you, Andy, are expecting it to do. You've built a race engine but expecting it to bimble around at lowish RPM with the throttle just cracked open without complaining. I think it's possible to achieve this, but you would need an ignition system that... Oh my goodness, this is a long message. Right, we're going to have to skip through that a little bit. So I think what Sidecar Body's saying is, you can read his message, it's on here, it's quite a big one. He's saying basically, and quite rightly so, if we had mapped ignition, we could do like a VAC advanced system where when it's on small throttle openings with a bad fill in the cylinder, we could crank in a load of advance which would clean it right up, which is effectively what I was trying to do by making it run static degrees, 20 degrees advance. These imps, the only reason I pursued it was because I've had imps with R23 cams, which are a low lift, big duration cam, and I've made them drive nice on small throttle openings where you can create the airspeed past the butterfly. If you get the fueling right and the advance half right, they will drive right. If you go and give them wide open throttle at 2000 RPM, the airspeed drops out and they go lean and they just blah, 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 blah. But you can get them okay. Better than that thing was. It was absolutely undrivable before we started, but hopefully Sam will be pleased with the result now. Right, thanks for your comment. Mike D6505. The series you're going to require a rear rad in the regs. Yes, fully aware of that. Stupid rule, but I'll make sure we've got a rear rad in the back to satisfy the rule book. Ray U7TP. When I commented about the Mercedes F1 pistons, it was because they increased the CR when hot by a determined expansion vertically. They could be illegal this year. Yeah, I think we need the compression to reduce when it's hot, not increase. But thanks anyway. Yeah, I don't think we'll be finding them pistons, so we'll just put that one to bed. But yeah, very interesting, the technology that's been made in recent times. Amazing. I mean, a totally different world to what I'm meddling in. I'm just touching the edges of old engines. Nothing like the computer analysis and the educated people that build modern F1 stuff. Thanks for your comment. Michael Bradbury. Oh goodness, still want to read this. Not too sure what to say this week. Not feeling the container dyno setup. Well, needs must make. Can't have fuel in the workshop. Fair enough, I understand. If it goes wrong, we don't want the place burning down. That would be not a good thing to happen. So it's got to be in a container in a separate cell, where if we did have a fire, in theory we could contain it and put it out. So that's why it's in there, mate. I know it may not be as ideal as we want it to be, but not everything in life is ideal, is it? However, got back from Thailand. Oh, well done, mate. How did your operation go? Had to get another flight, spent your time money. What? What did you spend the time money on? Latest fat head. Right, thank you for that, Michael. Hope you're well. Chris Val 78. Andy, keep that wonderful ramp. I used one many moons ago and can honestly say it made life much easier for a kind of driveline maintenance. Brakes, steering repairs, general service states will snap it up. Good luck with your old new venture. After that effort by everybody, you all deserve the rewards. Good luck again, Chris. Chris, lovely comment. Thank you very much. Yes, I love that ramp. Been using it. Absolutely can't wait to get stuck into my racing and other projects as well. Just got this unfortunate thing called work, which I should be grateful of, that we have to do first, but we will get my cars on there eventually and get racing. So thanks for your comment. That brought back Phil Hermetic. That brought back memories. Had a Mazda RX-3 with a 10A rotary engine, which I built thanks to a Haynes manual. Quite a demanding rebuild, and I was really fast like car, but it left a blue haze of oil smoke wherever it went. Cracking video, Andy. Watched it through in one. Phil, East Yorkshire. Phil, congratulations, mate. But if you watch the whole of that in one go without falling asleep, then that's very impressive. And also building your 10A rotary engine from a Haynes manual, yeah, brilliant. Good times. I hope you enjoy tonight's video and managed to watch it all in one. Thanks for your comment. Dougie788, I love your enthusiasm for all things mechanical. My first car was an Imp. I love that car. I should have never parted with it. It was another one to play with but couldn't find it anywhere. Oh, I want another one to play with but can't find any here in Southern Ireland. Well, they are out there. You need to speak to my mate Tim. He's got a few. I'm sure if anyone reads this comment, they might get in touch with you via your email or whatever, and we'll put a message underneath, and I'm sure we can find you an Imp. Thanks for your comment. Stuart Burgess 2409, that 1200 engine really sings in the car on the dyno. When you got it sorted out with some tweaking, just glorious. Hope other subscribers give you the hype boost in the comment box your channel deserves. Oh, thank you very much, that's lovely. Yeah, we get lots of positive comments, which is nice. We just ignore negative ones. We do positive on here, we don't do negative. Too much negative in the world. Thanks for your comment. Resto5741, interesting to see an Imp under a more dynamic load. Would you ever look at upgrading your dyno equipment? Well, if we won the lottery, we'd be having a really posh dyno, but it's so expensive, and the job with it only having me pedaling it and the overheads of the unit and everything else, it's a bit of a fine line, so we can't really justify investing lots of money into the dyno job because the job isn't that profitable. But as time goes by, I will treat myself to a new control module for the posh dyno, and hopefully we'll be able to do printouts and follow graphs and stuff, which will be a massive help when it comes to learning what these engines are doing. So thanks for your comment. Lotus Clan. Oh, this is my mate Andy. First comment he made, the first comment was literally the first. Ross, Dougie, please not now, mate. Was literally the first comment last week before anyone else managed to comment. I'm really competitive. Yes, I get it now. Sorry, I was being a bit thick. Dougie, please take that out. And sometimes silly. However, anyhow, it fell flat. So moving on. The dyno session with Simon's engine was fascinating. Maybe Simon should widen the gap between 4th and 5th to take advantage of the spread of torque, so it drops back to 5k rather than 6 after taking it to 859. And maybe with a higher fifth ratio, he won't get dropped for top speed at the faster circuits. Okay, house brick aero might work against him at top speeds, but if he's sitting in shelter behind a midget or a Lotus Cortina and not getting him space up the straight, he'd be close enough to have him in the next twisty section. George Bevan put some of his success down to specific gearing for circuits back in the day, and Simon's 100 foot-pound from 5k needs harnessing, not in silly mode this week. Thank you for your comment, Mr. Lotus Clan. Now, a few things. First thing is, chasing a car down the straight does work with a Hillman massively if you can get close enough to it, but it also puts like 5 degrees into your water temperature because there's no air going through the rad, so you've got to pull out again quick. But the other thing is, even though we had more torque there, as we discussed earlier, we're looking for work done, so it's a horsepower that pushes that brick through the air, and the torque is, it's torque multiplied by RPM divided by 5252 to give us a horsepower figure. So it's horsepower we're chasing. But I appreciate your angle and your comment. Thank you very much. Dennis Jones, my mate Dennis. Andy, impressive performance out of that engine for Simon. It's nice to see actual figures against running engines rather than quoted from a spec sheet. Yes, it was nice to get some decent figures. I do suspect they were a little bit on the generous side, but I'm quite happy to take them. Thanks for your comment. Hopefully your engine will be like 135 horsepower when it's got that posh head on it, because that will be the telltale. If that deep downdraft head works better because the inlet port's a better angle, we should see the horsepower and the torque further up the RPM range. Right, wonderful. Avatars. Oh, this is my mate Jonathan. You must have a better phone than me. My footage was bad quality. Got me thinking I could build a larder and do the tour. Daytime fun. I'd be the best on there at Alton for sure. I'm sure you would, Jonathan. Jonathan can drive. He does lots of rallying. Your phone, probably all that was wrong with it, mate, is I have a cloth. I have to clean the lens constantly because a smudged lens just blows my mind because it makes the quality of the video rubbish. So just check your fingerprints on it. The smallest fingerprint will knock the video quality. Peter Wilkie, this is Wilkie, my mate. Was Ed's car putting out a bit of smoke? Yes, Ed's car was smoking. It was a new engine at the end of 24, so we did 2025 of it. We had a lot of problems with ingestion of dust, which we thought it was going to have to come apart, but because I've moved units, I haven't done his new engine. So he is like one of the first to get his new engine in the next few weeks. I've bored the block, put liners in it, blah, blah, blah. We're going to use his head and a lot of his original parts and just basically reblock it with new pistons. And now he's got his air filtration sorted out. The new engine should last indefinitely. Right, Johnny 10 Jobs. That Bentley is interesting. Could you get the owner to explain a bit more? I didn't know the owner. That was my pal who was doing some work on it. Pretty sure it's a Derby. In other words, built by Rolls-Royce. Very high quality. Smoothness was top priority for those guys. I think the engine is overhead valve for the inlets and exhaust. Excuse me, sorry. Exhaust are side valve 3.5 or 4.25. Wow. It was overhead valve. Won it for 1939. It's amazing. I thought it was overhead cam as well. I don't know why, but yeah. It won't be overhead cam, will it? It'll be overhead valve. But yeah, amazing how advanced they were. So thanks for your comment, and it was an absolutely lovely car. Ian Cooper, 5615. Sorry to be a bike nerd, mate, but the pistons are Yamaha R1. Yep, we've got there, thank you. Kawasaki's never did a 5-valve production engine, and the pistons say 4XV on them too, which is first generation carved R1. Get them welded up and let's see the compression. See what it's like with some compression. Brilliant. I will do, thank you. Multi-hull 18CV 1PM. Funny thing, Andy, the previous Hillman was my 930. Oh, at Pips, that was your printout. My 930 Pip installed new Omex ECU for fuel and ignition. I had it remapped on a rolling road in D-side near Chester with a 1040. Did a lot better on torque and horsepower, but nothing like Simon's did. Well, Simon's got an all-steel 1200, so I think yours did all right, pal, but thank you for the comment, yeah. Simon Benoy, the man himself, halfway through so far. He has to come up for a break. He's probably gone for another can of Red Bull. Great for me to watch. Not sure about everyone else. Well, we all take different bits from it, and the beauty of YouTube is you can just fast forward the boring bits. But thanks for your comment, Simon. I'm only joking about the Red Bull. He wouldn't drink that. Right. Ditch the dinosaur. I've done a picture of a dinosaur. This is BSB's 1234. Just do road tests. So much better watching you on the road than the dyno rig. Thanks again. Great video. Oh, you're welcome. I did have to just put the boring road test on because obviously I didn't want to incriminate myself by putting a video of the imp getting a bit of stick down the road. You know, obviously I'd always adhere to the speed limits, but it's a bit of a rough interpretation as to what's considered what's the word for it? Sociably unacceptable. So, yeah, we just put boring, misfiring videos on of the car going down the road. Thanks for your comment. Jerry Ellis, 3847. My father had an Alfa Romeo Giulia Super. It had twin 40 DCOEs and it went sick. It had a cracked brass float. Great memories, yes, because when the float takes on fuel, it sinks a little bit, which raises the float level, which makes it go rich, and it sometimes drip out at the end of the carb. So brilliant there. Thank you for your comment. Clive Williams, 3661. I'm surprised the 1200 had wire gauze over the carb trumpets. Yeah, we've been through that, thank you. Apart from the ineffectual filtration, well, the wire gauze mesh actually reduces the effective free air area up to 50%. Just do the measurements and the math to prove it. I do appreciate what you're saying, but I've done the back-to-back, and with that coarse gauze, I'm sorry, just didn't see a problem with it. The reduction in the air will affect the airflow through the carbs unless they are simply oversized. A dyno run with and without the mesh will establish the true effect. A cold air box would be more suitable, especially since the carbs are drawing air from around the hot exhaust. Yeah, we've got a problem where we've got no room and with the chassis legs so close to the trumpets, we can't get an airbox on, which is what we've always had. What I will say is, think of the size of the trumpet with the mesh. and think of the size of the port just behind the valve throat. You know, it's less than half the size. So where is the true restriction? Is it at the trumpet or is it at the valve throat? And it's got to get past the valve as well. So think of it like that. Right, it's got 3 replies there, I read them. Benoit, had an airbox, but it fouls on the chassis leg due to the spacer plates. Yes, my fault, sorry. Such a long engine, it won't fit anymore. Austin Blanche, 1715. I was just going to ask the same question. The area of mesh would certainly be restrictive at high RPM, maybe on a big engine, not on one that's got, 300cc per pot. It's a small engine. Clive Williams, I would never put something on his engine that I thought would have, you know, if I thought it was going to be an issue, it wouldn't be there, trust me. Clive Williams 3661, Austin Blanche. I saw a test on a fuel-injected V8 where the original installation had a mesh covers on 2 all trumpets. The dyno test initially gave lower than expected reading that no amount of twiddling will cure. The conclusion was the injection system was restricting flow. Removal of the mesh gained 30 horsepower at peak horsepower. I spoke to the Genvig tech at Motorsport Show a couple of years ago. They were showing a Jag V12 with individual throttle bodies, the mesh covers, and they admitted the mesh does restrict the flow, although in the case of the engine they were showing the customer was restricted for space, and besides it was done as much more for a show than go. Right, so another comment basically saying that I'm wrong. Yeah, we should have took the mesh off, shouldn't we, to prove. Anyway, maybe another time we'll do more on this. Right, Mike D 6505, thank you for your comment, by the way. Buy some super magnets, attach them to the drain bungs to catch any particles. Also wire lock them. Over 28 years racing, the amount of people who lost bungs you wouldn't believe. Yeah, you are right, they should all be wired, and the magnet's not a bad call either. Certainly lets you know if something's going wrong. But with the Hillmans, what we tend to find is, because they're highly strung like a F1 engine, they're either absolutely fine and everything's going around great, or they're completely smashed up with nothing left. Oh, is that juice? Well done, Dougie. Right, 1 minute, mate. We're nearly there. We've got like 2 questions left. Mike D6505, the tracking gauges should have been sold on eBay, worth £100. Oh no, don't say that. They were slightly incomplete. Yes, Mr. Benoit's carbs are definitely rich on part throttle. In fact, I begin to think you had the choke out. Maybe you're talking about, that's from Chris Val 78. Maybe that's last year when the car was running. But I didn't think it was rich. But anyway, maybe, sorry, don't know. Sidecar bod 1441. If memory serves me correct, your offset bore engine actually had the bores angled rather than offset. In other words, there was virtually no offset at the top of the bore and the load of offset at the bottom. If this is the case, then would it have been very little offset when the crank was around 10 to 20 degrees after the centre? Which, Dougie, please, mate, just chill with them for 2 minutes, mate, 2 more minutes. Which is important part of the power stroke in terms of peak cylinder pressure and comb rod angles. That's why I think it was not successful as you were hoping it would be. Yes, Sidecar Bod, I think you are probably very correct in what you're saying, because the pulse, the peak of the burn just after TDC, we didn't have the best mechanical advantage. Even though I'd done the bore, if you look at the bore, our bore was at an angle like that. So say the crankshaft was here with the bore here. If you turn it round on an angle, you end up with the crank here and the bore here. So the fact I did it across the centre line of the bore was to make more advantage of the offset, to get the crank angle, the rod angle correct on the power stroke. So I did realise what it was doing. It did have offset. It just didn't show it. But we'll go into that another time. Right. Thanks for your comments. I look forward to seeing you all next Sunday at 7. Bye for now.